You sit down to eat. Your dog appears, sits beside the table, and quietly watches you. Most people assume this is a request for calories, but observing the actual mechanics of this behavior reveals a stark contradiction. This diagram displays the biological baseline for genuine canine hunger. When an animal is calorically desperate, that drive manifests physically. Vocalization and kinetic movement hit 100%. A truly hungry animal paces, paws, and whines. Yet the biometrics of the dinner table stare are entirely inverted. Vocalization drops to 0. Kinetic movement drops to 0. Gaze fixation maximizes. The dog remains perfectly static. While operant conditioning, specifically intermittent reinforcement, explains why a dog continues a behavior that has been rewarded in the past, it does not fully account for the quiet, stationary character of this observation. This suggests that while training reinforces the habit, the specific form of the stillness is governed by an ancient biological mechanism that prioritizes social monitoring over active caloric seeking. To understand this mechanism, we have to strip away human sentimentality and redefine the modern kitchen. From the perspective of animal behavior, a dining room is a localized resource node, a place where calories are predictably distributed. The dog's quiet presence at this node is an ethological fossil. It is a modern behavior that exists as a surviving remnant of an ancient survival script. Decoding this fossil requires applying the rigorous lens of predatory evolutionary biology. The true motive behind the canine stare is not found in the architecture of a modern home. Its origins trace directly back to the Paleolithic campfire. Early humans and wild Canis lupus operated in close proximity. As competing sympatric apex predators, they shared the same landscapes, hunted the same game, and maintained a strict spatial boundary. This diagram illustrates flight distance, the radius where wild animals instinctively flee an apex threat. Ancestral wolves viewed human campfires as high-risk perimeters. Over generations, wolves with lower cortisol tolerated a shrinking flight distance, edging closer. Breaching this threshold granted exclusive access to high-value calories. This specific spatial tolerance permanently altered their evolutionary trajectory, branching them away from their wild counterparts. In the subconscious architecture of the modern dog's brain, the kitchen table maps directly to that ancient campfire. The hardwired instinct to maintain proximity during resource distribution remains completely intact. Proximity is only half the equation. Observation serves its own distinct ethological purpose. In wild pack dynamics, feeding is a highly regulated event. Consuming calories places an animal in a biologically vulnerable state. It requires constant monitoring of external environmental threats and internal social hierarchies. Subordinate pack members continuously track the pack leader, relying on the alpha's posture to gauge the safety of the feeding zone. We can map this exact ancestral geometry onto the modern domestic environment. The physical variables change, but the vector of the gaze remains identical. The sustained gaze directed at you across the dining table is a continuous, active risk assessment protocol. The dog is running a biological diagnostic check. By watching you eat, they are verifying that the leader is calm, resources are stable, and the immediate environment is secure. From a dog's perspective, human daily routines are filled with high visual and kinetic noise. Humans move erratically, leave the territory, and generate unpredictable stimuli. Mealtime stops that erratic movement. When a human sits down to eat, their physiology shifts into parasympathetic dominance, the rest and digest state. As shown in this biometric data, heart rate declines, respiration slows, and muscle tension decreases. Dogs possess a highly derived neural architecture known as affective cognition. They are biologically wired to process human facial microexpressions. The sudden parasympathetic baseline of a seated human provides a perfect static calibration window. The dog isolates and analyzes these precise physiological cues. They actively seek out this relaxed state because a calm pack leader is the most legible indicator of immediate environmental safety. A dog observes your face during dinner because it is the most reliable data stream available for verifying emotional stability in an otherwise unpredictable world. This external observation is reinforced by internal neurobiology, beginning during ontogeny, the early developmental stage of a puppy. Maternal seeding establishes a hardwired neural link that associates caloric intake with physical warmth and survival. The delivery of resources triggers oxytocin release in the brain, encoding a deep neurobiological attachment to the provider. Domestication allowed humans to leverage these existing maternal pathways. The human-canine interaction activates parallel neurobiological circuits, using resource delivery to solidify the dog's attachment to the human pack. In pack dynamics, spatial exclusion from the central feeding ritual signals exclusion from the pack itself. Maintaining visual contact and proximity during the human meal is an active process. It is a continuous bid to ensure neurobiological and social inclusion. This visualization tracks the three scientific models: evolutionary proximity, affective cognition, and the oxytocin feedback loop, operating simultaneously. When merged, these data streams translate directly into the physical reality of the domestic dog sitting beside your table. The dinner table stare is an audit of social variables. It is an instinctual process of verifying safety, stability, and placement within the group hierarchy. Acknowledging a dog during this ritual closes the biological circuit. It fulfills a multi-millennia-old social contract between two apex predators. This silent observation represents the pinnacle of cross-species symbiosis. Every time a dog quietly watches a human eat, it operates as a living ethological fossil. It is a biological confirmation of mutual survival and permanent interspecies